Welcome to myprojectbazaar.com.
Now we are going to discuss about the product image retrieval using edge detection. Now we are going to discuss about the abstract for the process. The common problem in content-based image retrieval, that is CBIR, is the selection of features. Image characterization with the lesser number of features involving lower computational cost is also desirable. Edge is a strong feature for categorizing an image. In this process, we present a robust technique for extracting the edge regions by the edge detection methods like robots, shovel, preview, canny, log, etc. of an image, which is followed by computation of the global feature using gray level as well as shape information of the edge map. Unlike other existing techniques, it does not require pre-segmentation for the computation of features. This algorithm is also computationally attractive as it computes different features from limited number of selected pixels from the edge regions. Hence, it is more stable and then the more feasible for the retrieval process. Hence, due to the stableness, the classification rate will be more and then the retrieval rate also very more. Now we are going to discuss about the flow diagram for the process. At first, the query image, that is the input image, is taken from the dataset. The dataset is the folder which consists of the several categories of images. After getting any one category from the dataset, the corresponding image is undergone for the edge detection process. In this edge detection, we have took the 5 type of edge. First one is the robot's edge, then the second one is the shovel, third one is the preview, fourth canny, and then at last the final one is the log. After the edge detection, the feature is extracted by using the edge image. So to extract the feature, 3 steps will be followed. First one is the edge pixel matrix will be collected. After that, the finding the ones regions presented in the edge image, that is the ones will be the edge and then the other zeros will be the background. It will be eliminated. Then the third step is the index feature vector. Index feature vector is collected from the ones matrix. Hence, the index of the ones pixel is collected as an vector, that will be the test feature. After that, the classification will be done. In this classification step, we have to give the 3 things as an input. First one is the test feature, then train feature, and then the target. The test feature represents the feature of the input image, then the train feature represents the feature of the dataset, whole dataset images, and then the target represents the categories of the image. Here the classification is done by using the distance based classification method. After that, the image retrieval is done. In this image retrieval steps, the corresponding image, that is the relevant image present in the dataset, are extracted. After the image retrieval, the performance estimation is done by the parameters like accuracy, sensitivity, specificity, and error rate. By using these 4 parameters, we can justify our process is efficient. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015 and change the current directory. If you want to execute the code means, just right click in the main_GUI.yum and select the option run. Now the initial GUI design was open. In that, you can see the several push buttons in the left side for the controlling action and then the axis for the display purpose. First of all, you can see the file. In that, reset button is there. First click the input image. Now the dataset folder was open. In this dataset folder, you can see the several images presented here. Select any one image from the dataset. After the selection, the corresponding image is shown in the axis 1 with the title input image. After that, click the second push button, edge detection. In that you have 5 type of edges and the sixth option is all. If you click the first option means the robot edge will be detected, then Sobol, then private, canny and log. Or otherwise, if you click the all means all of the edges will be shown in the axis 2. Hence the robot edge image is this, then Sobol image is this, then private, canny, log is presented here. After that, click the button feature extraction. In this feature extraction, the feature is extracted from all of the edges, then the test feature is formed like this. After that, click the button feature matching. In this feature matching, it will take some time and then it will be matched with the database. Now the image which is matched with the databases are shown here. Now the relevant images only extracted and then the other images will not be extracted. After that, just click the button performance. After clicking the performance will be estimated for all the images. It will take some time. Now the accuracy is 99.6%, error rate is 0.4%, sensitivity is 96%, and then the specificity is 100%.
Thanks for watching this video.